I said when I was coming out here, if there were like 5 people here today, I was going to be thrilled because that would be like an awesome turnout. So I had no idea how many people would actually have interest in this talk. But in any event, my name is Tony Miller, as obviously says on the board. And we're going to talk to you a little bit today about OAuth, some implementation, vulnerabilities, issues, things, all that sorts of stuff. Just jumping right in, this is a little about me. I'm a managing consultant for FishNet Security. All the happy stuff you never really cared about me, all the usual alphabet soup behind my name. Yes, I even threw the CEH up there. I'll admit it, yes. Okay. Offered a few articles, lots of time spent as a mushroom in the corner being a developer and getting into application security sense. So, you know, like I said, I wasn't sure how many people are going to be interested in hearing about OAuth today. I wish I could stand up here and tell you I had some new big exciting O-Day vulnerability that I found in OAuth. No, I don't. As we're going to see, you know, OAuth20 was published in 2012. So now you're all wondering, okay, you got no new O-Days. You talking about something that's, you know, 12 years or 2 years old. Why are we talking about this? Well, the fact of the matter is, through various assessments, various different research, we're still finding the same vulnerabilities. And what's changed now is OAuth is no longer just this, you know, cool thing that Facebook and Twitter and all those guys are using to give us these cool integrations. We're seeing large enterprises implementing OAuth as ways to manage integration between their different systems that they're offering to their clients. And unfortunately, what we're coming across is these vulnerabilities, and they always seem to result, as the name of the presentation implies, from issues in the implementation. Either we're implementing things that aren't RFC compliant, we're just doing things that don't make a whole lot of sense. And what you'll see is that unfortunately the RFC itself leaves a lot of room for people to make some of these errors. So, where we're headed, I'm going to go through a brief intro of OAuth20. I'm not going to go real in depth. I could probably do a 2-day class on OAuth20 and still not cover half of its capabilities. I'll go through some of the big common attacks that maybe are a little scarier. And then I'll go through some of those other common implementation mistakes that people make that lead to other pretty scary vulnerabilities for them. And then finally, I'll give you some helpful links. If you're looking for more information, you're interested in implementing OAuth into, you know, some product or some platform you're putting together, I'll make sure we get you some of that information too. We'll get that up here for you. So, to start with, let's talk a little bit about OAuth20. As I mentioned before, it's defined in RFC. It's RFC 6749, if any of you care. They did obsolete OAuth1, the original version, when they released this. So, some things some of you may have heard, one of the authors actually resigned before this was released because he was unhappy with the way the specification was going. So I'll warn you now, you may hear some rants from me that kind of echo some of the things he had to say. You've already started to hear some of it. I might swear once in a while, so bear with me. But I think we're all big boys and girls, we can handle it. OAuth20 is an authorization framework. It is not a protocol. Please don't make the mistake of calling this a protocol. A protocol would be very specific about how things are accomplished, how communications occur, and what you're going to see is that OAuth20 leaves things wide open for you to make decisions how you want to do things. Great if you're a developer and you want things to be flexible and you want to be able to do things your way. Not so great if we're thinking about things like interoperability, which was, you know, one of the goals of OAuth when it originally started. As I said, OAuth is all about authorization. Note I said authorization, not authentication, okay? It's not meant, and indeed throughout the RFC you'll see them qualify over and over again that authentication is outside the scope of that RFC. This was meant to allow one application to pull data from another application in a way that didn't expose user credentials. Okay, I'm logging into, you know, maybe it's, you know, my email account or something and I want to pull in stuff from my Twitter feed or whatever. Okay. Now I don't have to plug in my username and password. Works great when we're talking about mobile applications. Certainly, we'll get into some discussion about that and some things that go on there. But in the end, I don't have to plug in user credentials. I'm not exposing that to my application. Instead, it gives me this third-party way of doing that so that that's protected. It also allows that other application that owns all of that information to manage the permissions of this other application such that it's not just wide open. Obviously, if I gave it my credentials, it would have access to everything I have access to as a user. We can limit that. We can use the scope and shrink down exactly what we're going to grant access to. And then finally, it allows for that user then to go back and revoke the permissions of that application to access data from another application. So those are optional things, but they're important concepts that really make OAuth what it is. Finally, just for those of you that have delved in OAuth1, if you haven't touched OAuth2 yet, be aware it is not backward compatible. That was never an intention from the get-go. So let me just go through some terminology, and this is just really so that you guys can be on the same page with me as far as some of the terms I'm going to use, you know what we're actually talking about. First of all, some roles within the OAuth process itself. First of all, there is this idea of the client application. So this is the application that the user is interacting with, that's going to go out to some third-party site, pull in that information. Resource owner is that user. That is the owner of all the data. He is the one that's going to decide whether or not that client application is truly authorized to access his information or her information. Then the resource server. The resource server, this is our, say, Facebook or Twitter or whatever that actually owns or houses all that data owned by the resource owner. And then finally, we have this concept of an authorization server. Now, in many implementations, we'll see that authorization server and resource server kind of are one and the same, at least logically, but they can be completely separate as well. Some elements that are also important within OAuth so you understand the process a little better. First one is the idea of this client identifier. OAuth2 talks about the option for doing client registration, whereby each client that's going to request data from a resource server is registered and known, and they're assigned a client ID. Now notice, I didn't say it's required. It's not. This is one of the things that's going to be very important as we move on through this. OAuth tries to be really flexible. They try to leave things open, but we don't require clients to be registered, and that can be problematic. It's represented within the OAuth transactions with client ID, so we'll see that later. Anytime you see something in that wonderful Courier new font, know that that's one of our many different parameters that we're going to be passing through the OAuth2 process. Redirection URI is a very important one, and as you're going to see later, and hopefully somebody's ears already perked up when you start hearing the idea of redirection URIs, yes, this is a URI to which the user will be redirected after they've authenticated, or authorized, excuse me, that client application. Scope is an optional parameter. What is scope? Scope is how I define permissions for that client application. You define various different scopes. This is defined by the interface itself, whichever authorization server it is that you're going to. And it's a space-delimited list of different permissions that can be requested. And they're cumulative. So if you put in read and you put in write, if those were two that were defined, hey, now they've got read and write. Is there a question back here? For authorization? Yes. OAuth2, and so, you know, I mean, kind of taking a quick step back and we'll roll on, but OAuth2, as we're going to see, there are some very secure ways to implement it, and it can be done right. The key is to understanding what those are, and that's actually, you know, kind of the point of this talk is to help open some eyes as far as where some of those things lie. So it's a perfect segue then into the next one I'm going to talk about, and that's the state option. And as we're going to see, there's a big potential within OAuth2 for cross-site request forgery attacks. This state parameter, again, is optional, but it shouldn't be, and you'll see why in a little bit. Client password is known as the client secret, okay? And this is exactly what it says. If I've got a registered client ID, this is a password. Again, we're going to see that this isn't always used. There's only certain cases where this gets used, and we'll talk about those in a minute. Authorization code is just a temporary code that is passed through the user agent and ultimately back to the client so that the client can go to the authorization server and get what we'll talk about next, which is the access token. The access token, this is our big dog right here. This is the one, we lose this guy, we expose this guy, we're in a world of hurt. This is the one that gets that client into that resource server and says, now I have access to whatever was granted under this access token. And then finally, the refresh token, because access tokens are supposed to be set to expire, the refresh token gives us a way that if I have an expired access token, I can potentially refresh, get a new access token. Again, optional in this case. One of the keys to understanding OAuth is to understanding the idea of grant types. So there's really 4 different flows that are defined within OAuth, and it's meant to be extensible so you can add more. So here they are. They're defined by the response type parameter, and there's 4 potential values for it. Authorization code, this is the one that's most commonly used. This is the one we see in Facebook. This is the one we see in Twitter. We see it all over the place. This is one that is very commonly used. It's kind of, I've seen it referred to as 3-legged authentication, although that's, you know, again, that's an authentication thing. But we'll talk quite a bit about authorization code and how that grant flow works. We're also going to talk about implicit grant flow. That's another one that's very common. This is one we'll see most often. It's one that's really mobile, optimized for mobile applications, so we see it a lot in mobile applications. And we're going to see there's some inherent weaknesses, though, that you need to be aware of. Not that they're designed there by accident, but they're there out of necessity, and you just need to treat it as such. 2 others that are there, they're kind of more for, I won't call it backward compatibility, but for very specific and rare cases. This resource owner password credentials is exactly what it says. OAuth provides a way that the resource owner could provide user credentials to the client application, and it's going to pass it through OAuth and access that backend application. If that makes you wonder, well, why in the heck would you use OAuth? Exactly. It's there really more to support some form of backward compatibility or temporary conversion over to OAuth2 rather than to be a permanent solution. And then client credentials is one step even lower than that. Again, exactly what it says. We assign the client credentials when they maybe associate with the authorization server, and that's all they ever need. And they basically have some predefined access to the resource server, whatever that is, and it's just open within whatever was defined. As we consider what flows we're going to look at and what grant type we want to use in our OAuth implementations, we have this idea of client types. And it's important that we understand what client type we're dealing with. When I say confidential client type, what I'm talking about is a client that is able to maintain the secrecy of that client secret. It comes right down to that. So we're talking about, as we'll see in the flows, a web application where the client's secret would be stored at the web server. That's our most common. And there may be some others where we have potentially, as long as you have that ability to protect that piece of data, that's going to be key. Conversely, then, public is any application that can't protect that. So that's our mobile applications, which are obviously easily susceptible to being reverse compiled. That is fat clients, same thing. Sometimes even we see, some rich media or JavaScript applications. These are where we're going to consider them public client types, and in those cases, now we want to use a different flow. So we've seen all this great, wonderful, cool stuff about OAuth. What could possibly go wrong? I mean, it literally, it's like liquor and fireworks. Separately, those things sound awesome. That's great. We sit down and we think about them all together and what they really mean and how they interact, and holy shit, what did we do? So let's talk about some of the things that can go wrong in our OAuth implementations. We'll start with the idea of the authorization code grant. So this is our first grant type, and I'm going to run through the flow for you really quickly. Again, I just want to make sure we're all on the same page and kind of understand the terminology I'm using and how this flows. So first of all, in an authorization code grant, this is where we have a confidential client. because we're going to be using client ID and client secret to secure certain communications and to authenticate the client to the authorization server. Yes, I did use authenticate there on purpose. So the resource owner is going to go and they're going to make a request to the client application. They're going to load some page somewhere that wants to pull data from this third-party resource server. Client application responds and says, hey, that's great. I'm going to go get some data from Facebook, so I'm going to redirect you to Facebook so that you can tell Facebook it's okay for me to get your data. So obviously, 302, here's your URL. Go talk to Facebook. So the resource owner logs into that authorization server. Great, cool. I get this little pop-up box, hopefully, that says, are you sure you want to let Facebook do this? They're kind of nefarious people. Don't let them do it. Are you sure? Okay, great. So I say, yeah, we're going to do that. Supplied in that redirect from the client was a redirect URI that we talked about before. So that's where the authorization server is now going to say, all right, resource owner, you want to give them access? Here you go. You're going back to this URL. And oh, by the way, I'm going to append this little authorization code on the end. That authorization code is what the client application is going to need when they want to go access data. So we'll see how that works. So that redirect happens. Authorization server says 302 back to the client. Here's your code. Redirect request goes to the client application. Client application says, oh, cool. There's my authorization code. I need that because now I need to go get an access token. So now we have the access token request. Client application takes that access code through JSON, something, 100 different ways this can be done, some type of web service usually. The client application is going to go talk to the authorization server, and it's going to say, hey, I've got this really cool authorization code you gave my user. Can I get an access token for that? Authorization server is going to look at their client ID and client secret, which, to take a quick aside, client ID and client secret are not recommended to be sent as parameters in the body of the request. RFC is very clear about this. So what does the RFC say we should use instead? Basic auth. Or, and here's where, the wonderfulness of our OAuth implementation, or you can use anything else you'd like. But of course, they don't specify any of that. So, most often, thankfully I'm not seeing this done in basic auth most of the time. It is sometimes a private communication, so could we get away with basic auth? Yeah, maybe. But I judge from at least a few giggles in the audience, some of you understand the implications of using basic auth in this case. So, assuming that all goes well, coming back to our flow now. So, client application sends the code, authorization server says, yeah, you're the right client, and you know what, that all works. Cool, yeah, I'll send you this access token. Here you go, this is what you need. From there on, the client application, pardon me, before I jump ahead to myself, like I said before, access tokens do expire. So the authorization server is going to include an expires in parameter, which just gives it a number of seconds that access token is going to be good for. The authorization server might give them a refresh token, it might not. Again, totally optional. Sometimes that might make sense, sometimes it might not. So if this interaction occurs over TLS, would I consider that adequate? Well, that's a loaded question. Does the RFC? Yes. The RFC is very clear. Oh, you must protect this with TLS if you've got client ID information going in there. And I would agree. But I would sure like to see a lot more. Again, reasons why I'd like to see more than basic auth being used. So the RFC does say absolutely you got to protect that with TLS, make it safe. Great. Okay. But that is problematic in its own ways, as you can imagine. So I would like to see more done there, and we're going to continue to talk about some of that. So once the client gets that access token, now all interaction with the resource server is going to include that access token. This is my bearer token that says, because I have this information, I am who I say I am, and I have the access I say I have. Great. Resource server says, hey, authorization server, is that true? Yeah, perfect. Cool. You're in. So that's the flow. So one of the things that you're going to see And this has gotten plenty of talk too. I mean, it's not like this is something new again, but I want to make sure we're still seeing way too much of this out there. So I want to make sure people are really aware of what's going on here. And that's the concept of this cross-site request forgery attack that really OAuth is susceptible to if we're not implementing it properly. And this is where we get into trouble with some of these parameters being optional. Okay? So let's consider for a moment, I've got a client application, foobar.com, and it wants to pull data from auth.com. If I'm an attacker, the first thing I'm going to do is I'm going to log into my own foobar account, and I'm going to go through and click the link that takes me to that authorization link for auth.com. Using my favorite little proxy, probably Burp Suite, like most of us, I'm going to grab a hold of that, intercept that response that comes back from auth.com, which includes my authorization code. There it is right here. If you guys can't see it, I know it's kind of small. This big cool string right here. All right, so that's my authorization code. Sweet. Now I drop that URL, or that, the browser's request for that URI. I don't want the browser to request that because that should be a one-time use item. Okay? So, now I've got that cool URL. What do I want to do with it? Well, there's so many things, but the one thing I'm thinking right now is, can I get another user who's already logged in to go visit that URL? Boy, that'd be kind of cool. All right. Get them to visit it. User's already logged in, and here's our little cross-site. Here's what makes a cross-site request forgery. Phishing attack or whatever, get them to visit this. Great, now what happens? So they send that off to the authorization server, to the client. Rather, the client takes that auth code, and it's going to go back to the authorization server and say, hey, I got this authorization code. Can I get an access token for that? Well, yeah. Auth says, sure, that's valid, hands them back their access token, and now what we've got is foobar.com just associated that user's account with the attacker's account on auth.com. So, what can we do with that? Oh, so many evil things, right? If this is one of those websites that's decided to use OAuth for authentication, boy, that attacker might have the access to use his auth.com credentials to get into the user's foobar account, correct? Maybe it doesn't do authentication, but maybe they're at least using it to display data. Couldn't I display fraudulent data now within the user's foobar.com account? You better believe it. Not cool. Not cool stuff. So, what do we need? We need a way for the client to be able to associate that original authorization request with that subsequent access token request. Now the good news. I mentioned it before, OAuth actually gives us a way to do that. It's this cool little tool I mentioned before. It's the state parameter. Why, oh why, writers of OAuth, is this not a requirement? Okay, has anybody here actually read the OAuth20 RFC or even looked at it at all? Okay, one maybe, okay. And that's fine. The reason I bring it up is one of the things they did when they wrote the RFC, they also wrote two other RFCs right away. One that talks about bearer tokens, but another one that did a complete threat model of OAuth20. Now, what does that tell you about your RFC when you have to do your own separate threat model at the point you release it? All right, so bear with me on that. So and they mention this in there throughout. It's covered over and over again. Use a state parameter, use a state parameter, use a state parameter, but for some reason it's still optional, and people aren't using it. Developers are looking at it, they see, oh, it's optional, I don't need to worry about it, screw it. I'm not going to do that. What the fuck do I want that in my shit for? No way. So instead, they leave it out, and we have that vulnerability. But what happens if they do include it? Here we go, this is awesome. I can throw a nonce in there. Now, when I redirect my users to the authorization server, I send them that nonce. The authorization server says, oh, cool, yeah, we'll process you, and hey, you know what, when I send you back, not only am I going to send you this auth code, I'm also going to send that nonce back. Now the client has the way that it can associate these two and make sure that that request with the new authorization code actually came from that authorization request and not something else. This is key. So, if we've learned anything so far, state should be absolutely 100% mandatory. The fact that it's optional freaks me out. So, We will move on for now. We're going to talk about implicit grants next, and I told you we had a couple different grant types to talk about. Implicit grants, this is where we've got a public client. So this is a client who we have to assume any data stored in that client is exposed. It could be, my Android app, and it's easy enough to, reverse out an APK and get all that wonderful gooiness that's on the inside. Same thing on iOS, it's no better. All right, we can do it right there too. We can pull out all sorts of great information. This could be some type of fat client that's installed on a computer somewhere. Again, easily reverse engineered, and hey, cool, credentials. So when we go down this path, the first thing we have to do is understand how this is going to work, because it is just slightly different from that authorization code grant. It's going to start with a request to the client application once again. All right, in this case, we're going to just assume it's a JavaScript application only because it's easy for me to describe. User sends in a request to this JavaScript client. The client says, oh, cool, I need to go get some data from resource server, so could you go over to auth server and tell them it's okay for me to do that? So the client, sure enough, redirects them. Resource owner, just like before, is going to log into that authorization server. The authorization server says, hey, this is okay, right? Yeah, okay, all right. I'm a little concerned, but we'll do it. Here you go. Oh, but wait, your request type says token. Are you really sure you want to do this? Because then what's going to happen when that user says, yeah, that's all right, he's responding with the access token. Hopefully you guys notice the difference there. Instead of responding with an authorization code that the client app is then going to use to get that access token, we just skip that step. Now, one important thing to notice here. Hopefully you saw this. The one difference here is instead of returning that as a parameter in that URL string, it is coming as a URL fragment. Anybody know why we want that to be a fragment? Thoughts? None. Okay. That's all right. URL fragments, upon redirect, will not be echoed in the URL. They are only for the user agent. So this is why this is kind of important, and why in a situation like this it needs to be a fat client, because we need a fat client that's got access to that information. So in this case, a JavaScript application with access to the DOM. Cool. Because in the DOM, I can find that URL fragment. That's like our document bookmarks and so forth. All right? So that request goes back. There's no fragment attached because it was a redirect. So that fragment gets dropped. But now the JavaScript application receives that request and says, hey, I need to know what that code is. I need that token. So it's just going to query it from the DOM. Awesome. If it was a Android application, it would be, within the response that's, logged somewhere within the Android application. There's a couple different ways actually to do that if you're talking mobile apps. I'm not going to teach a mobile class today, so we won't get too deep into that. But somehow the client application is going to go find that information in the user agent. Somewhere in the user agent, that information is being stored. It's going to pull that information, and now it has access to that access token. From here, the flow is the same. Every request to the resource server is going to include that access token, and every time that resource server gets that request, it's going back to the authorization server to say, is this still okay? This is cool? This one's still active? All right, good enough. So the big attack that comes up here most often, we've seen this word redirect. We've seen redirect URI pop up there a lot. Hopefully, for the pen testers out there, and hopefully even some of the developers too, when we start seeing parameters tossed around with URIs in them that say redirect, I'm hoping alarm bells go off all over the place in your head, because open redirects are a bane of many of our existences because they just don't seem to go away. People don't seem to get that this is an issue. So, some things that lead up to that. I mentioned before, implicit grants need to be, or are optimized to be used with public clients. So they need to be treated as such. As you saw, the access token gets exposed to the resource owner. That doesn't happen when we're doing authorization code grants. It's only in these implicit grants. So what does that mean? Well, it's exposed within the user agent, so anything with access to that user agent has the ability to get that access token too. Access token could potentially also be exposed in proxy or web logs. Okay. Depends on log settings and so forth and yada, 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 but you get the idea. There is no client authentication, and that's key to remember too. All right, you saw in the authorization code grant, yeah, client ID, client secret could pass through whatever basic auth or whatever authentication you choose to use. The only way to authenticate a client with implicit grants is to look at that redirect URI, and hopefully we did client registration so we can validate it. And we can look at interaction with a resource owner. So if you think of your Facebook on your phone, you go in and it says, you know, you get redirected from something else to Facebook, and you get, again, that box that asks you, is it okay for this application to do this? That's the only thing that's truly authenticating that that client really is what it says it is. So what happens if we don't validate that redirect URI, or we don't fully validate that redirect URI? Well, consider this. Here's a redirection that comes from the client. Users in the client, they click on a link, it says, I want to go to, you know, good site and get some information from them. If the attacker can take one of those, modify it, and change that redirect URI to his evil site, the text in red up there, what happens to the flow? Well, first of all, the resource owner makes that interaction, he gets that redirection back. He gets, if there's no validation of that URI, he's going to get redirected to that malicious site. So now, after the user has said, yeah, this is great, I want this client to have access, the authorization server sends them to the malicious site, sends along with it the access token, so there's nothing the malicious site has to do with the authorization server. All he's got to do is have some JavaScript there that can get at the DOM, get in there, grab the access token, and now that malicious site is talking to that resource server. Resource server is going to send an access token over and say, is this access token valid? Authorization server says, of course it is. I just gave it to him. And you can see the results. So again, this isn't a new vulnerability. Open redirects have been out there forever. It's something we've known about, but it's something that doesn't seem to get a lot of attention. And indeed, as we're starting to look at enterprise implementations of this, it's even worse. Because now people assume, well, these are two servers on my internal network, even though they're using OAuth to talk to each other, all this should be safe. But then they do something like this. So the mitigation here is actually pretty simple. The easiest way, or the most effective portion of that mitigation, is really make sure you use client registration and validate the full URI. Now, what we've seen in the past, and it still goes on, is in some cases here, that authorization server is only validating maybe the domain. So it looks and says, okay, this request comes from xyz.com, I can let it go there. Well, we'll see in a minute why that gets to be problematic. So we want to validate the full redirect URI. Now, of course, for the client programmers out there, they're saying, well, but that redirect URI is how I get them back to where they were in my application before. Why don't we manage that on the client side and bring them back to a static location so we can register this and make it secure? Another piece of that, we need to make sure we're requiring that interactive approval or authorization from the resource owner. There are applications, especially in enterprise environments now, that are skipping that step. So again, the user themselves has no opportunity to say, well, that's not the URL of the site I was just on, or that's not the name of the site I was just at. No, I don't want them. I mean, that step's there for a reason, but unfortunately it's getting omitted when people are in an enterprise setting where they think this is just safe and okay. Getting into some defense in depth strategies for this, ways we can go beyond just the simple, okay, I validated the redirect URI. What about restricting client IDs to only one type of grant? So their response type can only be one value for each redirect URI that they supply. Well, what this does is it keeps attackers from potentially taking, maybe I've got, the same endpoint that's processing incoming OAuth for both my web application and my mobile, and, my mobile application, of course, uses implicit. My web application hopefully is using, that authorization code. But now that attacker can go in through the web application and have it do the implicit because there's nothing here that's binding those two together. So this is a good defense in depth. Man, I never thought that was that hard to say before. Obviously, I haven't had enough beer yet today. They're serving, right? Last I checked, they weren't, but I need beer. So in any event, like I said, good defense in depth strategy. And then finally, remember, when you're dealing with implicit grant types, you need to treat these as inherently dangerous, okay? So let's minimize the amount of access we're giving them on the resource server. Especially if we're not using scope to define the access, I hope that your predefined level of access is quite tight. The other thing that is strongly recommended here, and we'll see some examples of problems related to this later too, shorten the expiration on that access token. At least try to minimize the attack surface by shrinking the amount of time you're ultimately vulnerable. All right, so let's move on. Does anybody remember seeing this logo? Think about maybe 2-3 weeks after Heartbleed. Anybody remember this? CNET was all up in arms. Oh my God, the next Heartbleed's been discovered. Blah blah blah. So some researcher found what he thought was a great, cool new bug, and he created a neat logo because, well, Heartbleed had a cool logo, so I want one too. And I think he reported it as an ode to Facebook, and Facebook kind of told him to shove off. But in any event, he called it covert redirect. So why did Facebook tell him to shove off? Well, let's talk about what is covert redirect. Covert redirect is simply just combining a couple of different vulnerabilities, okay? It's a scenario where the authorization server isn't doing enough to validate the redirect URIs, first of all. So like I said before, we should be registering a full URI, complete down to the last directory and page. If that's not happening, if like Facebook was doing at the time, and I think in at least one of their interfaces they still are, if all I'm doing is validating the domain, okay, that presents one of two pieces needed. The other part here is that the client has an open redirector. So not at the authorization server, but actually at the client, there's an open redirector. So what does this allow me to do? Hopefully it's obvious. The authorization server is only going to validate the URI down to the domain. It's going to say, okay, this request is for this client, which is a valid client, and they're at this domain. Okay, perfect, I like it, let's go. Well, now, like you saw before, the attacker can supply a different redirect URL, but in this case, what he's going to do is that redirect URI is going to point to that open redirector on the client. So of course, if I'm redirecting you to an open redirector, I can send you wherever I want you to go. And we're going to see something like this. So you see auth server, blah, 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 blah. Here's all my info. Here's my redirect to the client site. But then it goes to this OAuth redirector, which then sends me off to evil site. So is this anything new? No. Ultimately, this is exactly all sorts of things we already knew. Clients shouldn't have open redirectors. We've been screaming this as security professionals for years and years and years. If you're going to have a redirector on your site, it better validate where it's redirecting people to. That's pretty simple. So despite all this media splash, and like I said, CNET got all excited and started reporting it as the next Heartbleed, and I think a few other media outlets jumped into that too, and whatever, and websites went up. It didn't take real long for a bunch of other blogs and tweets and everything else explaining why this was nothing new at all. There is a cool website out there. If you look for covert redirect, you'll find it. If you want to see some other proofs of concepts he's done with different, Google APIs was one that was susceptible, Facebook was another, and he ties it in with New York Times and a few others. Google it, you'll find it, it's cool. It's fun to watch, but no worries. All right, so let's move on. I'm going to talk about some other common implementation things. As I mentioned before, sometimes these things are happening because we're not compliant with the RFC. Sometimes they're happening just because the RFC lets us get away with too much. So let's take a look at this. Again, the following examples are all real life. However, they have been, my standard disclaimer, modified to protect the identities of, in this case, the pretty much foolish. So one of the first ones we have is authorization code replay. If you remember before, I said authorization code should be a one-time use temporary element. It should not be reused. In fact, if you look at the RFC tells you, although they don't tell you how long it should be valid for, they just say make it short. They do say it has to be one time, and they go so far as to say you should. I would again consider this a must, but they say should. If you detect that an authorization code is being replayed, you should revoke any access tokens that were associated with that authorization code. I agree. So what's happening, and what we've ungodly, I can't believe we're doing this, but we are seeing this still, is, all right, here's my first request. I go in. So in this case, I was looking at somebody's client and their interaction with the authentication server, because they actually wanted me to look at their OAuth implementation, which was cool, good idea. And so the first request goes through fine. Yeah, great. It signs an access token here. Everything's good. If you make note, it starts with 1029, ends with VDDD3. Perfect. All right, we know what that one is, right? So having my handy dandy little burp suite tool, we'll just fire this over to the to replay it again and send through the same, literally sent the exact same request. I didn't modify this at all. Sending the exact same request with the repeater and burp suite, and bam-o. Well, that sucks. Because now I've got two access tokens, and indeed I did go back and I checked the original access token and this one and logged into the client site with or into the resource server with both of them and was able to pull data. So this is an example of not being RFC compliant. The RFC says very clearly what we need to do here. So when I see something like this, that was pretty much my reaction to it. It gets the double face palm because that's ridiculous. Read the RFC. That's a simple one. Not invalidating those OAuth codes after they're used. You're just opening it up for, you're undoing any security that was built into OAuth2. Excessive token life is another one. And this one you can debate. There's different issues on depending on where your excessive life is. But consider this. So here it is. It's an access token response this time. This is the JSON response back. And you can see, okay, we got this really cool access token. That's awesome. Big, cool stuff. I think this was like a SHA hash, if I remember right. So, okay, cool. You know, that works. And then it expires in a year. That's seconds, folks. So that's 1 year. On top of that, you gave him a refresh token? Why? Oh my God, why? So and that's one of those, the RFC again, it talks about refresh tokens and authentication or access tokens and their lifetime, and it's really vague, and rightfully so. It should really be based on, we should understand our applications and know how long that is. In this case, this was a banking application. I don't need to say more. That, as I said, protecting the foolish, that's why I won't give you their name. All right. Some other ones, there are some issues. Weak code and token values. So we've got this authorization code, we got this access token that are kind of the keys to our castle here. If we're using weak code or weak values for those, they're easily guessed. Anybody recognize what's going on there? Some of you do, I hope. What does that look like? Anyone? Anyone? Bueller? All right. So, base 64. Anybody got their base 64 calculators with them? No? Okay, I'll do it for you. There you go. Base 64 decoded, it's this string, auth/10123/ this really long number. What are those? Well, auth is just a word. That's just a seed value, apparently. 10123 is the client ID of the client I was working with. And that last string, well, boy, looking at the length, okay, that sure looks like sure as shit. It's a timestamp. All right, if I look at the timestamp here, and I look up there, yeah, they're pretty damn close. So in this case, it's the auth code, right? So maybe not as big a deal if I wanted to brute force this. Obviously, it'd be easily brute forced, but if they're at least doing this as a one-time code, I've got kind of a race condition is the only way I'm going to get there and actually be able to do something with it. I've got to get in with the right value between the time that the client initiates that authorization request and the time they go and do the access token request. Unfortunately, this customer who I was working with didn't let me. I wanted to go look at their interaction between the client and the authorization server, because I'm willing to bet if this is going on here, their access tokens probably look the same. So consider this on an access token. That would be far bigger deal. That'd be, that's a token with some life to it, and brute forcing that is obviously no problem at all. Then finally, client secret. I talked about this before, and I talked about using the correct grant type for the type of client we have. Consider an Android application, and an Android application that's using the authorization code grant. Authorization code grant, as we mentioned before, has client ID and client secret. That client secret is the only thing we have to authenticate the client to the authorization server. So bad enough that we want to do that, 10 times worse when you see this. Pull the APK, look at strings XML, and oh my God. What I really love here, though, this is the cool part. Like, this is an MD5 hash. So they went through all the trouble to generate an MD5 hash, and then they stuck it in strings XML, completely free text. Even if you told Stephen Colbert this, even he'd do this one. I mean, you got to be kidding me. Come on. So, a lot of these things, they're not new attacks. Okay? I mean, they're the same attacks we've seen over and over again in many different applications, but because we're seeing now, we're using OAuth and we're using it in particular in an enterprise setting, people just assume it's safe. Okay, great, wonderful. I'm going to just do this. I don't need to worry about all this optional stuff. I don't, RFCs are too long to read. I get it. I see, I got this off the web forum. Someone was out on, whatever and told me this is how I can do it. Great, cool. I'm just going to use this. And so that's why we're starting to see so much of this. So what have we really learned here? Well, first of all, we've used that it is incredibly important to make use of client registration. Why, oh why, the authors of this RFC decided that client registration should be optional, and we should have this idea where we can totally authorize clients that are completely anonymous to us. I will never know. Yes, we have the user authorizes them. Yeah, because users are so freaking reliable. All right, redirect URI is a must. That should be a part of that client registration every time. Even if you do client registration, you don't have to pull in the redirect URI. You don't have to, according to the RFC. You want to talk to me? I'll tell you why you have to. I think I've shown you why. Know what type of client you had. We've seen the vulnerabilities that result from that. All right, if we have a public client and we're using auth code grants, we're in trouble. You've seen why. Using the appropriate grant type to go with them. Follow the RFC. I know it sucks. It's long. It is. I read the whole thing repeatedly the first time I implemented OAuth2, and I read it probably 6 times before I stood up here and talked to you guys. But it is worth it, and there's a lot of information in there. I, would recommend their threat model as well. The key there, though, is don't ignore those optional features. We talked about state. I didn't get deep into scope, but scope's another one that's optional, and why would we not want to have different access levels? Maybe we don't need them, but let's make sure we're restricting that access where we can. Protecting your tokens and credentials, I mean, that's like security 101, hopefully for all of us here. So those are the things that are leading to issues. Those are the things that we're seeing over and over again in OAuth implementations, especially within the enterprise. As this expands more into the enterprise, I think we're going to see more attack vectors like this because developers aren't that well versed on it. And it is just so open to give them options for so many ways to implement this that it does get confusing and it's tough. So with that in mind, here's some helpful links for you. Links to the RFCs. You guys probably know how to find those anyway. But again, RFC 6749 is the OAuth. 6750 is a short one on bearer tokens that we're using within OAuth and kind of how to secure those. 6819 is the threat model. I do recommend if you're working with OAuth, you take a look at that threat model. It will talk about some of the things you saw here. It won't go nearly as in depth, but it will go through a lot of that information. Take a look. There's 2 really good OAuth2 tutorials. This first one is by Jacob Jenkov. It's great. It is awesome. It tell you everything you want to know about grant types and everything else. It's awesome. And then that last site has an intro on it, but it also has the rantings of Aaron Hammer, who is the author that resigned from the OAuth20 RFC. So he's got a lot of good insight both on the goods and the bads, and he gives you a good intro too. So with that, folks, I really appreciate you hanging around. I know we're running a little behind, so I'm going to get out of your way here. But there's my information. If you've got any questions, concerns, whatever, you want to bounce something off of me, I'm more than happy. Shoot me an email, hit me up on Twitter. I'd definitely be happy to talk to you guys. So thanks again.